In this session, we are going to deal with some of the important questions regarding the chapter electricity. So the first question is, when electric current is passed, the electrons move from, the options are high potential to low potential, B, low potential to high potential, C, in the direction of the current, D, against the direction of current. So we know when electric current is passed, electrons move from, that is question. So the electrons move in a direction which is opposite to the electric current, that is obvious. But it is asked, how is the movement of electrons happens? So the electrons move from the negative terminal of a battery to the positive terminal. So that means option B is correct, that is from low potential to high potential. The second question, electrical resistivity of any given metallic wire depends upon option A, its thickness, B, its shape, C, the nature of the material, and D, its length. We know that resistance R equals rho L by A, where L is the length of the material, A is the area of the material, and rho is known as the resistivity. So here the question is, the electrical resistivity depends upon. So the electrical resistivity of any given metallic wire will depend upon the nature of the material. So the correct option is option C. So the next question, the charge possessed by an electron is 1.6 into 10 raised to minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. We know the equation that is connecting the charge, the number of electron and the electronic charge is Q is equal to N into E. We are already given that the charge possessed by an electron is 1.6 into 10 raised to minus 19 coulomb. So Q is already given. We know what is the E, isn't it? So Q is related to N and E as Q is equal to N into E. But still there is another equation which connects Q, I and T, isn't it? That is Q is equal to IT from the basic equation that current is equal to the charge flowing per unit time. So I equals Q by T. So from that, if you cross multiply, you will get Q equals I into T. So there are basically two equations, Q is equal to I into T and Q equals N into E. Since both of them have one side of the equation as Q, you can equate both of them. So you will get NE equals I into T. We take such a comparison because we are given current as well as a charge possessed by an electron. So from the given quantities, you want to find the unknown quantity, that is number of electrons represented by N. So by equating both equations, NE equals IT, you will get N equals IT by E. So we have already given that the time is 1 second, I is also 1 ampere and the charge of electron is already known, that is 1.6 into 10 raised to minus 19. So substituting in the equation, you will get N equals 1 into 1 by 1.6 into 10 raised to minus 19. That would give you 6.25 into 10 raised to 18 electrons. So the number of electrons that will flow per second to constitute 1 ampere current will be 6.25 into 10 raised to 18 electrons. Moving on to the next question. Two wires A and B are of equal length and have equal resistance. If the resistivity of A is more than that of B, which wire is thicker and why? So we know the basic equation connecting resistance, resistivity, length and area of the material is R equals rho L by A, where R is the resistance, rho is the resistivity, L is the length and A is the area. So it is already given two wires A and B, their length as well as resistance are equal, isn't it? So we are asked which wire will be thicker if the resistivity of A is more than that of B. So if we rearrange this particular equation, we will get rho by A equals R by L. But we know that that is equal to a constant that we can represent it by K. Why do we do so? It's because it's already given that they are having same length as well as resistance. So R by L will be definitely a constant. So rho by A equals R by L, which will be a constant that can be denoted by K. So rho by A gives you a constant K. So that will be rho is equal to K into A. Since K is a constant, if you give the value, for example, say it's 1, what will be the proportionality? That is, rho or resistivity is directly proportional to area. So that means for different materials having same resistance per unit length, greater the resistivity material wire, then it will be having more cross-sectional area. So since resistivity is more than that of the B for A, then the wire A will be also more thicker than that of the B. So resistivity directly proportional to area in this case, and hence wire A is thicker than that of the B. Third question regarding this is, in the circuit diagram given in here, suppose resistors R1, R2 and R3 have the values 5 ohm, 10 ohm and 30 ohm respectively, which have been connected to a battery of 12 volt. We are asked to calculate the current through each resistor, total current in the circuit and the total circuit resistance. So this is regarding a 3-mark question. So it should be answered accordingly. We are given basically 3 quantities, R1 equals 5 ohm, R2 equals 10 ohm and R3 equals 30 ohm. So by using this, we can draw a circuit diagram as this. The resistors are connected in parallel, and along with them we have a voltmeter, ammeter, a key as well as a voltage source. So the voltage source is of 12 volt. So first we are asked to calculate the current through each resistor. Since we are given a diagram in which it is connected parallelly, the potential difference across the battery V is equal to 12 volt, and this will be the potential difference across each of the individual resistor. That is one of the basics for such a circuit which is connected. So the first question, to calculate current in the resistors, we need to use the Ohm's law. We know the basic equation of Ohm's law, that V equals I into R, isn't it? So to carve the current in I1 that is flowing, then we have to rearrange the equation, isn't it? So that we can get V equals IR, so here we need to get I1. So how can we rearrange? So we can rearrange it as I1 equals V1 by R1. But we know the potential across each resistor will be same since it is a parallel circuit. So I1 equals V by R1 we can substitute. So V is 12 volt for every resistor, that's fine. So first one, to calculate current I1 through R1, it will be I1 equals V by R1. V is already 12 volt and R1 is given as 5 volt. So it would give you, I1 gives 12 volt by 5 ohm, that is 2.4 ampere. To calculate the current I2 through R2, we will use the equation again as V equals IR, and we correspondingly write as R2 as well as I2. So I2 will be given as V by R2. V is 12 volt and R2 is given as 10 ohm. So I2 will be given as 12 volt by 10 ohm, that will give you 1.2 ampere. And finally, the current I3 to the resistor R3 will be V by R3. So V is again 12 volt and R3 is given already in the question as 30 ohm. So you will get 12 volt by 30 ohm as 0.4 ampere. So you are asked to calculate in the B section the total current in the circuit. So you have already found current I1, I2 and I3 through resistors R1, R2 and R3. So it's pretty easy. You just add the current in each of the resistors to get the final sum. So 2.4 plus 1.2 plus 0.2 ampere will give you 4 ampere as a total current in this circuit. So third section is to calculate the total resistance. Since we know this is a parallel circuit, the net resistance is given as 1 by Rp, or the resistance in a parallel circuit is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So R1, R2 and R3 are already given. So you can substitute the values to get 1 by 5 plus 1 by 10 plus 1 by 30 is equal to 1 by 3 ohm. That is the unit of resistance. Since 1 by Rp equals 1 by 3 ohm, the Rp or the net resistance in the parallel circuit will be reciprocal, which will give you 3 ohms. So next question, define electric power expressed in terms of potential difference V and resistance R. B, an electrical fuse is rated at 2 ampere. What is meant by this statement? And the C is, an electric iron of 1 kilowatt is operated at 220 volt. For which of the following fuses that respectively rated at 1 ampere, 3 ampere and 5 ampere can be used in it? So the first question A is asked to define electric power. We know power is the rate of doing work. So electric power means it is the rate of doing work by an energy source or rate at which electrical energy is dissipated or consumed per unit time in electric circuit, which is termed as electric power. So power P is work done per unit time, or it is same as the electrical energy dissipated per time. So P equals VI or P equals V square by R. So the second question, it is asked, an electric fuse is rated at 2 ampere. What do you mean by this statement? That is, it will mean that the maximum current that will flow through it is only 2 ampere. The fuse wire will melt, the current exceeds the 2 ampere value through it. So the C section, the question is, electric iron of 1 kilowatt is operated at 220 volt. Find which of the following fuses that respectively rated at 1 ampere, 3 ampere and 5 ampere can be used in it. So we are already given power equals 1 kilowatt. That is equal to 1000 volt, isn't it? And also the voltage is given as 220 watt. So the watt power is 1 kilowatt and volt is 220 volt. So the current drawn and the power and the voltage can be related by the equation P equals VI. So from that you will get I equals P by V. So P can be substituted from the question as 1000 and the V can be substituted as 220. So you would get 50 by 11, that would give you 4.54 ampere. So that is the amount of current that can be drawn according to the given conditions. So moving on to 5 more questions. The same current flows through the electric line wires and the filament of bulb, yet only the filament glows. Why? That is, it is given same current flows through the electric line wires and filament of bulb, but only the filament glows. What is the reason for that? We know that the electric line wires offer extremely low resistance to the flow of current. So they do not glow because negligible heat is produced in it. The filament of bulb glows. Why? Because it becomes red hot due to the large amount of heat produced, as it offers high resistance to the flow of current through it. The B section, the temperature of the filament of the bulb is 2700 degrees Celsius when it glows. Why does it not get burned at such high temperature? So the filament of bulb, when it glows at 2700 degrees Celsius, will not get burned because the tungsten metal of filament which is used is having certain properties. The main properties are that they are having very high melting point of the range of 3380 degrees Celsius, and it is also having high resistivity. These are the main factors that contribute that even the filament of the bulb which is having high temperature doesn't burn even at the high temperature. So the third part is the filament on an electric lamp which draws a current of 0.25 ampere is used for 4 hours. Calculate the amount of charge flowing through the circuit. So we are already given current as 0.25 ampere and the time is given as 4 hours. So we need to convert it in terms of a second. So for that we multiply it with 60 into 60. So 4 into 60 in 60 seconds, isn't it? So the amount of charge which is flowing through the filament of the electric bulb can be found from the basic formula that relates current, charge and time, that is I equals Q by T or Q equals I into T. So I is already given us 0.25 ampere and the time we have converted into seconds, which would give you 0.25 into 4 into 60 into 60 seconds, which would give you the final charge of 3600 coulomb. So the fourth question is, an electric iron is rated 2 kilowatt at 220 volt. Calculate the capacity of the fuse that should be used for the electric iron. So we are asked to calculate the capacity of the fuse that can be used in the electric iron. So we are already given certain quantities, that is power equals 2 kilowatt. So when we convert this kilowatt in terms of watt, you will get 2 kilowatt as 2000 watt. It's from the basic relation 1 watt equals 1 kilowatt equals 1000 watt. So 2 kilowatt equals 2000 watt and volt or the potential is given as 220 volt. So from the basic equation P equals VI, we are already given P as well as V. So we need to find the unknown quantity I. So substitute for the known quantities, you will get 2000 equals 220 into I. So from that I equals 2000 divided by 220, which would give you the final answer of 9.09 ampere. So moving to the next question, derive equation for Joule's law of heating and explain one of its application. This is one of the relevant questions that is to be explained. So we know the basic Joule's law of heating and they are also asking to find one of its main application. So let an electric current be flowing through the resistor which is having a resistance equal to R. So let's consider that the potential difference across the resistor is V. And of course there will be charge that is flowing through the circuit for the time T. So we know the work done in moving a charge of Q of potential difference is given by W equals V into Q. So V is a potential difference, Q is a charge. So work done in moving that particular charge of a potential difference V from one point to another would be W equals V into Q. So since this charge Q flows through the circuit for time T, how we will be relate both of them? So the power input P to the current can be given by the following equation as P equals V into I, isn't it? But we know the basic equation for electric current that I equals Q by T. So if we substitute Q by T equals I in the equation, we will get finally it as P equals V into I. So since the electrical energy is supplied for time T, we can finally obtain it after multiplying both sides of the equation by time T. So P equals Vi, and now since we consider it for a particular time T, we can write it as P into T and Vi into T. That is, we are multiplying both sides of the equation with time T. So P equals Vi and multiply T in both sides of the equation, you would get P into T as V into I into T. So that would finally give you as P into T equals V into I into T. So for steady current I, the heat produced in the time is equal to VIT, that we already know. So H can be written as V into I into T. So according to Ohm's law, we know that V equals I into R. So if you substitute the value of V in the equation 4, then you will get H equals IR into IT, because we already know that I into R is V according to Ohm's law. So it would finally give you H equals I square RT. So finally we get into the Joule's law of heating equation as H equals I square RT. So one of the common application of Joule's law of heating is the fuse which is used in the electric circuit. And what is the main function of the electric fuse that we use in the circuits? The main function is that they will protect the circuits and appliances by stopping the flow of any unduly high electric current. So the fuse which is placed in series with the device consists of a piece of wire made of a metal or an alloy, and that will be having an appropriate melting point. For example, it could be of aluminium, copper, iron, lead, etc. So, if a current which is larger than the expected value or specified value flows through the circuit, then what happens? The temperature of the fuse wire increases. So, this melts the fuse wire and breaks the circuit. So, the appliances are safe and the fuse will be sacrificing its own to save the other appliances and the circuit. So, the fuse wire is usually encased in a cartridge of porcelain or some similar material which have metal ends. So, and this is used for different domestic purposes, which is rated by different current as 1 ampere, 3 ampere, 10 ampere, etc.